meaning it gets wide. So now let's take a look at something when it's being multiplied by a coefficient of 1/2. So now our coefficient is between 0 and 1, right? It's 1/2 is 0.5, which is between 0 and 1. So in this case, you would do a vertical compression, meaning it gets wider. So when you're multiplying by a constant, by a coefficient that's a whole number, it gets narrow. If you're multiplying by a coefficient that's between 0 and 1, like a fraction or decimal, it gets wider. Now, if you're multiplying by a coefficient in the inside of your function, you notice the 2 is on the outside here, the 1/2 is on the outside, but 2 is on the inside of the function, right? It's both being squared. So when we have something, a coefficient being multiplied on the inside of a function, we have a horizontal shift. And if it's greater than 1, a whole number, it's a horizontal compression, meaning it gets wide. Now in this case, same thing as this, meaning it's a horizontal, our A, absolute value of A is less than 1. So it's between 0 and 1, right? We're going to also have a horizontal shift, but it's going to get narrow. Okay, so when you're multiplying a coefficient on the outside of the function, where you're multiplying the coefficient by the function. You're multiplying 2 times, right? This is 2 times the function of f of x, right? F of x was x squared. Then I multiply 2 times the function. So that's a vertical stretch if it's greater than 1. If you're multiplying it by a value that's greater than 1, it's a vertical stretch. It gets more narrow. If you're multiplying just the x, right, just by 2, which is greater than 1, it's a horizontal compression, meaning it gets wide. If I'm multiplying the function again here by here is similar to the first one, 2x squared. I'm multiplying 1/2 times the function of x squared. 1/2 is between 0 and 1, so it's a vertical compression. It gets wider. Here, we are multiplying 1/2 times x, not times the function. We're multiplying times x, so it gets narrow. It's going to be a horizontal shift. Since it's between 0 and 1, it gets narrow. So now let's take a look at how the graphs look. So let's graph them. So here we have x squared. Our first graph, a parabola starting at 0, 0. Then we have our transformation, which is 2x squared. And let's see what happens. So the green graph represents our original function, f of x equal x squared. Then the blue graph is our transformation function, 2x squared. I'm multiplying 2 times the whole function. So that means since 2 is greater than 1 and I'm multiplying it by the function, it's a vertical stretch. So it gets more narrow. As you can see, the blue is more narrow than the green graph. It's more narrow. Now let's see what happens if I multiply it by 1/2. Oh, it got wider. See, the blue represents the 1/2 x squared. It got wider. Okay? Now, let's see what happens when I multiply it by the inside, right? So meaning 2 times x squared. Okay, again, now it's a horizontal, okay? So now let's move on to graphing piecewise functions, okay? So here they're asking us to graph our piecewise function of f of x equals -3 if x is less than -2, f of x equals x squared if -2 is between, if x is between 1 and -2 and equal to them, and f of x equals 2x plus 3 if x is greater than 1. And they want us to graph this piecewise function. Now again, this is called a piecewise function because we're graphing pieces of each function. We're not graphing the whole graph of -3. We're not graphing the whole graph of x squared. We're only graphing pieces of x squared, and that piece is where x is between 1 and -2. So let's go ahead and work on that. Okay, so we have our piecewise function, f of x equals -3 if x is less than -2. We have x squared if x is between -2 and 1 or equal to, and then 2x plus 3 if 1 is greater than x. If x, now whenever you have an inequality, remember you always read it with the variable first. So this would be incorrect if I said 1 is less than x. I would have to read it x is greater than 1 because we don't know what x is. So we can't say 1 is less than x if we don't know what x is. So x is greater than 1. You always start with the variable. So now we have to graph, right? There's 3 things I have to graph. So I'm going to make a table. Now, since there's specific rules, our graph is going to have specific rules. It's going to look a little different. So it's always best to make a table, okay? So we're going to make an x and y table for each one. So I'm going to make the first one, which y equals -3. Okay, and I'm only graphing this graph, y equals -3, because remember, f of x is the same thing as y equals, right? These are three different graphs. Y equals -3, y equals x squared, y equals 2x plus 3, but each of them have specific rules. So I only want to graph y equals -3 for when x values are less than -2, not equal to, so -2 or less. So that's -2, -3, -4, so on. All these numbers are less than -2. But I can't do it. There's nothing to plug in, right? So everything is just -3. Okay, now let's see how we're going to graph this. We have an inequality that's less than, meaning I'm going to start my graph with an open circle. Right? Since it's not equal to. Since it's not equal to, I'm going to start with an open circle. Now, my x continues, right? As you can see, I can continue. There's a lot of numbers that are less than -2, right? This continues, meaning I end the graph with an arrow since it continues. Okay? Now let's do the other graph. We have our x. We have x squared. So y equal x squared. And then we have our y values. And they only want me to graph this f of x equal x squared for the values of x between -2 and 1. So I'm only graphing the values of x that are between -2 and 1. So it's -2, -1, 0, 1, and 1. Right? -2, -1, 0, 1. They only want me to graph the x values between -2 and 1. Now, our inequality has an equal sign, right, for -2. So starting at -2 has to be a closed circle, starting at the point -2. And now, this doesn't continue. My x values don't continue, right? They stop at 1, and it includes 1 because it's equal to. So at my end point at 1, I'm also ending this graph with a closed circle. So I start with a closed circle because it's equal to, and I end with a closed circle since it's equal to and it's in between two x values. So now I'm just going to plug in, right? So -2 squared, -1 squared, 0 squared, and 1 squared. Okay, so now let's do my last graph. Okay, now I'm only graphing 2x plus 3 for the x values that are greater than 1, right? X greater than 1. So we're going to start at 1. Do we start at 1? Yeah, but it's going to be a open circle at 1, right? Because it's not equal to. So you always start your table at the number that the inequality starts at. So here, our first inequality started at -2. We started at -2, but it's a not equal to, so it would be open circle. And it ends with an arrow since x continues for all the numbers that are less than -2. Then our second graph, we started at -2 because that's where inequality starts at. We end at 1 because that's where inequality ends at. We start and end with closed circles to represent our equal to inequalities. And it indicates that our x value is between -2 and 1. Our third graph, we're going to start at 1 because that's where our inequality starts. And we're going to go to our values of x that are greater than 1. So that's 1, 2, 3, 4, 5, 6, and continues, right? So this graph starts with an open circle at 1 since it's not equal to, right? We're not really including that 1. And it ends with an arrow to indicate that there's infinite numbers of value of x that will work for this, right? Because it's any value of x that's greater than 1. So now I'm just going to plug in. So 2 times 1 plus 3. Then we're going to do 2 times 2 plus 3. 2 times 3 plus 3. And so forth, okay? So now let's go ahead and graph this. So you're just going to graph the way you graph a piecewise function is you just literally graph each table on its own. So you're just graphing 3 different graphs. Okay, that's all you're doing. You're graphing this one first, but remember you start with an open circle, you end with an arrow. You then draw this graph, but you start with a closed circle, you end with a closed circle, and then you graph this table, but you start with the open circle and end with an arrow to show that the x continues. So let's go ahead and look at that. So I already graphed it here. So let's take a look at the first graph, y equals -3 for x is less than -2. So as you can see, the graph starts at x equals -2, which is right here, and they only graphed y equals -3 for the values of x that are less than 2. So, and look how it starts. The graph starts with an open circle, right? Let me zoom in on that. Okay, so it starts at -2, and it starts with an open circle. You see that? Open circle. Let me zoom in even more so you can see that open circle. Okay, here it is. Open circle. Okay, it starts with an open circle, and it just doesn't end. But on your test, you would show that it ends with an arrow, right? Because it just continues, right? Because we're just graphing the line. Here's the line, y equals -3, but we're only graphing it for the values where x is less than -2. So from -2 and all the way to -infinity. But we start off with an open circle. You see how the circle here is open. Now, y equals x squared, you see this, it's not the full graph of y equals x squared. We're only graphing pieces of y equals x squared. We're graphing the piece of y equals x squared where x is between -2 and 1. And look, closed circle. You see that? It starts with a closed circle to indicate that it's equal to, and it ends with a closed circle to indicate that it equals to, right? My values are between my x values run between -2 and 1 only. They don't continue, right? There's no arrows here. This graph does not continue. It's between 2 x values, both closed circle to indicate the equal to. Now we have our y equal 2x plus 3. And I'm only graphing the line y equals 2x plus 3 for the values of x that are greater than 1. So starting at 1, right? This is 1 over here. Starting at 1 and going to positive infinity. So you see this graph, y equals 2x plus 3, starts with an open circle to indicate that it's not equal to. Not equal to, we represent that by starting it with an open circle. And then it just continues to all the values of x that are greater than 1, right? We start here, our graph starts at where x is greater than 1. Here's 1, and it continues to where x is greater than 1. And that's how you do piecewise function graphing.